Okay, if you can turn to page 8 in your packet. On the top, it's kind of like a do now. This is a review. It says convert each of the following angles to radians. So if you forget how to convert from degrees to radians, just look back in your packet and then try A, B, and C on your own. Then you can hit play and see how you did. Okay, so we know to change from degrees to radians, we're going to multiply by pi over 180. All right, so if you want, you could put the 30 over 1 and just multiply across. 30 times pi would be 30 pi. And then in the denominator, 1 times 180 is just 180. And we're going to leave it in terms of pi, so we're really just going to simplify the 30 over 180. So 30 over 180, or really 3 over 18, simplifies to 1/6. So this would be 1 pi over 6. Which I'm just going to write as pi over 6. Okay, so then 45 degrees. Same thing, multiply by pi over 180. And if we put the 45 over 1, when we multiply the numerators, 45 times pi is 45 pi. And then 1 times 180 is 180. And since we're going to leave it in terms of pi, we're just simplifying 45 over 180. So that would simplify to 1/4. So 1 pi over 4, which is just pi over 4. Okay, and then letter C, same thing. We're going to put 60 over 1 and multiply by pi over 180. Okay, so that would be equal to 60 pi over 180. And again, since we're leaving it in terms of pi, we just have to simplify this 60 over 180. So that would simplify to 1 over 3, 1/3. So 1 pi over 3. So we could just write that as pi over 3. Okay, so now if you look below here, what they want us to do, this is called our special angles chart. Okay, your 30-degree angle, your 45-degree angle, and your 60-degree angle. These are called your special angles. And basically, this chart you are going to have memorized. If you want to find where these angles come from, there's definitely more in-depth videos online that you can look at. I probably even have one from the past. But I'm going to show you the trick as to how to remember what sine of 30 is, and sine of 45, and sine of 60. And then, cosine of each of these angles. And these have to be memorized. It is so important to have these memorized. Now, on top of this chart, since we just found 30, 45, and 60 degrees rewritten in terms of radians, I'm going to put the radian measure on top of each of these. So we said that 30 degrees can be rewritten as pi over 6. So I'm going to write this as pi over 6. And then 45 degrees is pi over 4. And then 60 degrees is pi over 3. Okay. So I'm going to fill out this chart, and I'm just going to kind of show you what I do to memorize it. All right, so we always put sine, and then cosine, and then tan. It's easy to remember because isn't tan equal to sine over cosine? All right, I'm going to write that down just so we remember that from our notes, okay? We know that tan of theta, tan of an angle, is equal to sine of our angle over cosine of our angle. Okay, that was from earlier on in the packet. Okay, so it goes sine on top, then cosine, and that's equal to tan. Sine, cosine, tan. All right, so now this is how it works. For sine and for cosine, all of these are equal to fractions, and each of those fractions have a 2 in the denominator of the fraction. Okay, now the numerators, starting with sine, it just goes 1, 2, 3. And for cosine, it goes in reverse order. It goes 3, 2, 1. Okay, now each of these numerators, you're going to put a radical on top of, but just the numerator, not the whole entire fraction. So this would be radical 1 over 2. But think about it. What is the square root of 1 equal to? Well, the square root of 1 is just 1. So this one you can leave as 1 over 2. Okay, now, when I put the radical on top of the 2, well, the square root of 2 doesn't simplify, so I'm going to leave that as radical 2 over 2. And when I put the radical on top of the 3, the square root of 3 doesn't simplify, so I'm going to leave that. So basically, all the denominators are 2, and this goes 1, 2, 3. And you put radicals on top of all the numerators. The reason why this doesn't need 1 is because the square root of 1 is 1. Now for cosine, let's do the same. We're going to put radicals on top of all the numerators. So the square root of 3, which that doesn't simplify, the square root of 2, which doesn't simplify. And if you did put the radical on top of the 1, the square root of 1 is just 1, so you can leave it without the radical. So that's how sine and cosine work. Okay, now tan. Well, tan, I do it like this. Ready? Tan of 45, right in the middle there. It just gets a big old 1. Now if we're looking at tan of 30, they both get a radical 3. Now, this one right here, see how we have a 30? Okay, we have a 3 there. This one gets an extra 3. What we do is we take that radical 3 and we put it over 3. Okay, this one, since there's a 3 in 30, it gets an extra 3 down there. And this one we're just going to leave as is. So for tan, the middle number is 1. Both of the numerators are a radical 3. And then for tan of 30, since this has a 3 in it, this gets the extra 3. Okay, we put it over 3. This is what all of our special angles are equal to. Okay, if you plugged in your calculator sine of 30, it would give you 1/2 or 0.5. If you plugged in your calculator sine of 45, it would give you a decimal. It would give you, 0.7 something. And then if you plugged in radical 2 over 2, it would give you that same decimal. Okay, but we want to remember the exact values of all of these. So what that means is we don't want to know, like, remember how I said sine of 45 is equal to a decimal, approximately 0.7? We don't want to know that. We want to know the exact value of sine of 45. If we want to know the exact value, you leave them as is. You leave them as fractions. Okay? All right, so now let's look at the bottom of our hand, at the bottom of this page here. Okay, so on the bottom here it says sines of trigonometric functions. When we say sines, we're just talking about, are they positive or are they negative? And when we talk about trigonometric functions, okay, this right here, I mean, so far we only know 3 of them, but the trig functions we know are sine, cosine, and tangent. So sine, cosine, and tangent. Those are the trig functions we know. Now, if we look at, if these are representing our 4 quadrants, okay, we know this is our first quadrant, the top right. That's where the x values are positive, the y values are positive, everything is positive in the first quadrant. Now, as you work your way around the quadrants, we always go counterclockwise. So quadrant 2 is going to be over here. And if you keep going counterclockwise, quadrant 3 is going to be down here. And then as we keep going over here, quadrant 4 is going to be over here. So starting in quadrant 1, we'll see an A, S, T, and C. Okay, now what does like dorky math teachers say to help us remember the order of this? A, S, T, C is, okay, A, S, T, C is all students take calculus. Okay, I'm sure you can think of something much funnier and much better to say, but I feel like every math teacher I've ever had, that's what they always said. We came up with other things in school, but all students take calculus, okay? So that's how we remember the order of it. Always start in the first quadrant. Now, let me just go around and say what all of these stand for. Now, if you notice, we have an S, just like sine starts with. Here we have a T, just like tan starts with. And here we have a C, just like cosine starts with. A doesn't really start with anything, but you know what A represents? A represents the word all. Okay, let me write that in here. A represents all. Okay, and what that means is all of the trig functions that we know at this point are positive in the first quadrant. So the only 3 trig functions we know are sine, cosine, and tan. So if we're working in this first quadrant, all three of these are positive. So let me write that out. Okay, so for right now, we only know three of them, but all trig functions are positive in quadrant 1. Everything's positive here, okay? If I said, is cosine positive or negative in quadrant 1, you would say positive. All right, if I said, is tan positive or negative in quadrant 1, you would say positive. Everything's positive here. Okay, now as we go over to quadrant 2, we see an S. Now, although S stands for students, it also stands for sine. Okay, so the S stands for sine. What that's telling us is sine is the only one of these three trig functions that is positive in the second quadrant. So let me write that out. Okay, so sine is positive. It's the only one of these three that's positive in the second quadrant, okay? And if I was in the second quadrant, cosine would be negative and tan would be negative, okay? S stands for sine. Sine is what's positive. Now the T, what do you think that stands for? That stands for tan, okay? Tan is positive in the third quadrant. Okay, so T, it stands for take when we say all students take calculus, just so we remember what goes where. But T also represents that tan is the only one of these three trig functions that's positive in the third quadrant. Okay, sine is negative here and cosine is negative here. Tan is what is positive. And then the same thing applies in the fourth quadrant with the C. Okay, so C stands for cosine. So cosine is the only one of these three trig functions that's positive in the fourth quadrant. So if I said to you, where is sine positive? Sine is positive in quadrant 2. And it's also positive in quadrant 1, right? Everything's positive there. If I said to you, where is cosine positive? You could say cosine is positive in quadrant 4, and it's also positive in quadrant 1. Everything's positive there. Now, what if I said, in which two quadrants is tan negative? Well, since we know tangent is positive in quadrants 1 and 3, wouldn't it be negative in quadrants 2 and 4? Okay, so it's really important as we progress, with the trig functions, that you know which quadrants, which of the functions are positive and negative in. Okay, so if you can turn to page 9, you'll see at the top here it says reference angle. So let's just first talk about what a reference angle is. All right, if you look at these pictures down here, right, you'll see right here, this is a first quadrant reference angle, okay? We know the initial side of an angle is always on the positive portion of the x-axis. So this would be like our initial side right here. And the angle's going to open up, and it's going to land in the first quadrant, okay? Now, if we look at a second quadrant angle, we know that the initial side of the angle, again, is always on the positive portion of the x-axis. And as this angle opens, here's the terminal side. Now, if you notice, when we're in the second quadrant, okay, you'll see the reference angle is actually outside of the given second quadrant angle. And that's because your reference angle is the angle that's formed between the terminal side of your angle and the x-axis right here. Okay, so here the reference angle, here's your terminal side, here's your x-axis. So your reference angle is the angle formed between the terminal side and the x-axis. So if we go back to this first quadrant angle, here's our terminal side, and here's our x-axis. So the reference angle in this case is actually the first quadrant angle itself. Okay, now, before we look into the third and fourth quadrant, I just want to look right here. The reference angle, it's a positive angle because we're opening in the counterclockwise direction. And it's acute, which means it has to be between 0 and 90. Okay, so let's underline that. Positive and acute means that the angle has to be between 0 and 90 degrees. And it's formed by the terminal side of the angle, so where the angle terminates, and we just said that is going to be our x-axis. Okay, so if we look in I'm going to move this up a little. If we look in the third quadrant, right, here's our third quadrant. Okay, so in the third quadrant, right, here's our initial side. So let me just draw that. Here's our initial side. And this angle is going to open up until the third quadrant. And this is the terminal side, right? It terminates in the third quadrant. Now, we set our reference angle. I'm going to go back up here. It's the positive acute angle formed by the terminal side and the x-axis. So here's our terminal side. And this whole thing is the x-axis. But since it has to be an acute angle, If we were to go from here to here, that would be obtuse. That would not be acute. So we're going to have to go this way up to the x-axis. This would be our reference angle. Okay, here's the x-axis, and here's the terminal side. So this is our reference angle, okay? This is an acute angle. Okay, and then if we're in the fourth quadrant, we have our initial side. The angle opens up all the way up into the fourth quadrant, and here's our terminal side. Now let's go to the definition of a reference angle. It's the positive acute angle formed between the terminal side and the x-axis, okay? So from here to here would be the acute angle. We don't want to go this way to the x-axis because that would be obtuse. So from here to here would give us our reference angle. Okay, just a couple other notes that we see at the top. Angles in the first quadrant are their own reference angle. Okay, so we could see that. Here's a first quadrant angle, and because this is the terminal side and this is the x-axis, the reference angle is the same as just the angle. And then it says quadrantal angles. So for example, 0 degrees, 90 degrees, 180. So let's look at a 90-degree angle, for example. A 90-degree angle would be right here. They don't have a reference angle. If they're not within the quadrants, they don't have a reference angle, okay? Only angles within the first, second, third, and fourth quadrant have reference angles. All right, so let's look at some examples so you can get a better idea of what's going on here. All right, so at the bottom of the page, the directions for 1 through 4, it says sketch the given angle theta. Okay, so in number 1, they give us an angle of 125 degrees. Now, we know as we work our way around the axes, right? This is 0 degrees, 90 degrees, 180 degrees. So figure 125 would have to fall within the second quadrant. So I'm going to draw the initial side, and then I'm going to draw my terminal side ending up in the second quadrant. So this right here, it says sketch the given angle theta. So I'm going to label that theta. So theta equals 125 degrees. Okay, now it says shade the reference angle. Now, if you recall, the reference angle is the angle that's formed between the terminal side and the x-axis. Now, it has to be acute, so it can't be this angle because that's an obtuse angle. That's more than 90. So if this is our terminal side, the only way to form an acute angle and get us to the x-axis is right here. In the second quadrant, this is where our reference angle is. So it says to shade that, so I'm just going to kind of shade that in a little, okay? So here is our reference angle. Okay, now it says in letter C, find the measure of the reference angle. So we need to come up with some way to find the measure of this reference angle here. Now let's think about it. We know that a straight line is 180 degrees. So if this whole thing is 180 degrees, and we know from here to here is 125, couldn't we just do 180 minus 125, and that'll leave us with this shaded portion here. Let's do that. If we do 180 minus 125, that'll give us 55 degrees. Okay, so for part C, our reference angle, I'm just going to write this right here, would be 55 degrees. And if you want to check, just to make sure you got this right, just add it up. 125 plus 55 would add up to give you 180 degrees. Okay, so now you may want to try number 2 on your own. Follow the same directions and try to do it like we did number 1. And then you can hit play and just check how you did. Okay, so now in number 2, it gives us an angle of 253 degrees. So let's think about this. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees. So 270 is more than 253. So I figure 253 would fall somewhere in the third quadrant. Okay, so let me draw my initial side. Let me change back to red. The initial side, and it's going to open up and wind up somewhere in the third quadrant. It's going to be a good portion of the way through the third quadrant. And here we're going to label that theta. Theta is equal to 253 degrees. Okay, now, part B wants us to shade the reference angle. And again, the reference angle is going to be the angle formed between the terminal side and the x-axis. Now, if we were to go from the terminal side this way to the x-axis, it's going to be an obtuse angle. So we don't want that. We want it to be an acute angle. So if this is our terminal side, and we want to get to the x-axis, if we go this way, that would be an acute angle. Okay, so this is where our reference angle is going to be. So it wants us to shade that in part B, so I'm just going to shade it black like we did in number 1. Okay, so we're going to shade this right here. Okay, now we have to figure out how many degrees there are in this reference angle. Okay, letter C says find the measure of the reference angle. Now, let's just think about this. If we know that this entire angle is 253 degrees, and we know from here to here is 180, if we want to figure out what this part is, can't we do 253 minus 180? And wouldn't that leave us with this shaded part right here? Okay, so 253 minus 180 is equal to 73 degrees. So our reference angle in number 2, I'm going to just put that right in here, would be 73 degrees. Okay, so if you flip to the next page, the directions for number 3 and 4 are the same as the directions for number 1 and 2 on the previous page. Now with number 3, it's a little different because if we look here, they're giving us the angle in terms of radians. So the first thing we're going to want to do is we're going to want to figure out how many degrees that is. All right, so we know to convert from radians to degrees, we multiply by 180 over pi. And then if you want, you can just multiply straight across. So 15 pi times 180 would actually be 2,700 pi. And then 4 times pi is just 4 pi. So if we simplify this, the pi's cancel off. And 2,700 divided by 4 is 675 degrees. All right, so that's a huge angle. So what that means is if the initial side of our angle is right here, okay, our angle is going to open up. If it opens up 675 degrees, well, if an angle were to, let's say, open 90, and then 180, and then 270, and then 360, it would have to keep wrapping around until it reached 675 degrees. So if we wrapped around a full 360 degrees, if we kept adding on, right, 360 plus 90 would be 450. 450 plus 90 would be 540. 540 plus 90 would be 630. So then 630 plus 90 would be 720. So that would be too far. So it would wind up somewhere here in the 4th quadrant. Now, what we're going to do is, let's just say, we can draw the initial side of our angle right here. But then to show that our angle wrapped around and didn't just stop in the 4th quadrant, to show that it wrapped all the way around and kept going, we're going to draw kind of like a little spiral. Ready? We're going to draw this. We're going to show that our angle went around the full circle, and then it kept going like this until it ended up in the 4th quadrant. And when it did, this big angle right here was a total of 675 degrees. So I'm going to label that as theta. They said to label the original angle theta. Theta equals 675 degrees. Okay, so we really had to wrap around to get there. Now, the next thing I want us to do is label the reference angle. Shade the reference angle. So if this is our terminal side, we know the reference angle is the angle between the terminal side and the x-axis. Now, we're not going to go from the terminal side this way to the x-axis because that would be an obtuse angle, right? That would be greater than 90 degrees and less than 180. If this is our terminal side, if we go this way to the x-axis, that would form an acute angle. So I'm going to shade that right here. That's my reference angle. Okay. Now, let's think about, in order to find the measure of the reference angle, 675 degrees. Let's figure out what that would be if we were to have just started off at the initial side and opened right up and wound up here. Okay? Basically what we want to do is, if we want to figure out what 4th quadrant angle corresponds with 675 degrees, we need to subtract off a full circle. Okay, we need to subtract off a full 360 degrees. Because if we do that, if we take this big angle, right, and take off 360 degrees, if we take off this circle right here, wouldn't that leave us with this part of it, this part of the spiral right there, which is the fourth quadrant angle that's coterminal, which means it shares a terminal side with this big angle. So I'm just going to subtract 360 degrees from here, which gives us 315. And that'll tell us the fourth quadrant angle that is coterminal with this big angle of 675 degrees. Now this is going to help us find the reference angle. Okay, if we want to figure out the number of degrees in this little angle right here, well, let's think about it. If we know a full circle is 360 degrees, and we know that from here to here is 315, can't we just take the 360 and subtract the 315 from it, and that'll leave us with this shaded angle right here, our reference angle. All right, so let's do that. So 360, a full circle, minus 315 degrees is going to leave us with that shaded portion. So this 45 degrees is our reference angle. All right, so this is 45 degrees. Okay. And then finally, number 4, you may want to try that one on your own. That one's pretty straight to the point. It's pretty quick. So try that on your own and then hit play and see how you did. Okay, so the first thing they want us to do in part A is to label the given angle. So if we have a 45 degree angle, here's the initial side. And since from here to here is 90 degrees, 45 would just be half of that. So we'd wind up halfway through the first quadrant. So our terminal side is right there. Okay, and we can label that theta. Theta equals 45 degrees. Okay, so now they say to shade the reference angle. Well, we know the reference angle is the angle between the terminal side and the x-axis. Well, since we want it to be an acute angle, this is the acute angle formed between the terminal side and the x-axis. So we could shade that. I'm just going to be consistent with what I've been doing. We're going to shade that black. Okay, now if we want to find the number of degrees in the reference angle, well here, the reference angle, whenever we're in the first quadrant, the reference angle is the given angle. So the reference angle is also going to be 45 degrees. So when it's in the first quadrant, it's pretty easy. All right, number 5. So which diagram represents an angle measuring 13 pi over 20 radians drawn in standard position and its reference angle theta? Okay, well, let's just, let's first figure out what this is in degrees. So if we take 13 pi over 20 and change it to degrees, we would multiply by 180 over pi. Okay, so if we multiply across, that would give us 2,340 pi over, and then 20 times pi is just 20 pi. All right, and then if we simplify that, the pi's cancel off, and 2,340 divided by 20 simplifies to 117 degrees. Now, I have to be honest, I'm looking at all these pictures. We didn't even have to do that, because think about it. Doesn't every single picture show an angle of 117 degrees? 117 degrees would be in the second quadrant, right? The second quadrant is between 90 and 180 degrees. Now, isn't this terminal side there, as well as this one, and this one? Okay, they all show an angle. Well, actually, no, not this one. This one's going in the negative direction. So this is the only one it can't be, okay? If this is your initial side and you open up in the clockwise direction, that would be a negative angle. So I'm going to get rid of that one. Although technically, if you wanted to find an angle coterminal with it, it would be positive 117. Okay, but that's not what we're looking at. Now, let's go through the answer choices. They also want us to find the reference angle theta. Okay, well, if this is our terminal side, the reference angle is the angle between the terminal side and the x-axis, but it has to form an acute angle. What they did was they went from the terminal side to the x-axis, and they made theta be an acute angle. So that's not the reference angle. So that one's out. Okay, choice 3, let's see over here. They went from the terminal side to the y-axis. We never go to the y-axis, so choice 3 isn't our answer either. So it's got to be choice 4, so let's see why. Okay, here's our 117-degree angle, and then here's the terminal side, and the reference angle is the angle formed between the terminal side and the x-axis, forming an acute angle. So this choice 4 shows that exactly. All right, this has been a super long lesson, but we're almost done. So if we, let me just move this up here. If we take a look at number 6 and 7 on the bottom, it says in each of the unit circles shown below, determine the coordinates of x, y. Now, if we remember, x corresponds with cosine of the angle, and y corresponds with sine of the angle. Okay, so you can just write that out in your notes right here. The y value corresponds with cosine of our angle. I'm sorry, the x value corresponds with cosine of our angle, and the y value corresponds with sine of our angle. Okay, it goes alphabetically. X comes before y in the alphabet, C comes before S in the alphabet. That's how you can remember which one goes with which. Okay, so let's take a look at number 6. Now, there's a lot that goes into these problems, so you have to take into consideration everything we've learned. Okay, so the first thing we're going to want to do is, we don't really know. I mean, we said x, it stands for cosine, right? And y stands for sine. We don't know what cosine of 240 degrees is. And we don't know what sine of 240 degrees is. So what we want to do is we want to find the reference angle that corresponds with a 240 degree angle. So remember, the reference angle is the angle formed between the terminal side and the x-axis, and it has to be an acute angle. So that being the case, we're going to look at this portion of the x-axis. So this is our reference angle in here. Now, to find the reference angle, if we know that from here to here is 240 degrees, and if we know that a semicircle, right, a half a circle is 180 degrees, if we take this full angle of 240 degrees and subtract off the portion of it that we know, this 180 degrees, wouldn't that just leave us with this right here, this reference angle? So we know our reference angle is 60 degrees. Okay, I'm going to just label that. There's our reference angle. And this in here is 60 degrees. So really what we're trying to find now is cosine of the reference angle, cosine of 60 degrees, and we're trying to find sine of 60 degrees. Okay. Now, if you notice, I left a little space here because sometimes we have to insert negative signs and sometimes we just leave it alone. Now, there's 2 different ways you can think about it. Okay, we've already talked about, let me just change colors here. We already talked about all students take calculus. Okay, now, since we're in the 3rd quadrant, right? This is the 3rd quadrant angle. T for tan. Tan is the only trig function that we've learned about so far that is positive. So what that means is, in this quadrant, cosine is negative, so I'm going to put a negative in front of this. And also, sine is negative, right? Tan is the only thing positive here, so I'm going to put a negative in front of sine as well. So the other way you can think about it, and this is a good way to think about it, think about if you were plotting a point. If you go back, doesn't that make the x-coordinate negative? And then if you go down, doesn't that make your y-coordinate negative? So if you go back and down, it's going to be negative, negative. Okay, so now we just have to, let's do this. Let's bring down the negative sign, and then cosine of 60. So now you're going to have to think about what we talked about earlier. You have to think about the special angles chart. Okay, so here it is right here. So cosine of 60 is equal to, here's cosine and here's 60, it's equal to 1/2. Okay, so I'm going to bring down 1/2. And then let's take this negative sign and bring it down. And then Sine of 60, so here's sine, now let's follow it over to 60 degrees, is radical 3 over 2. So this right here, these are the coordinates of xy when we're looking at a 240 degree angle. So to plot this point on the unit circle, you would have to go back 1/2 and down radical 3 over 2 units. Okay, so let's do the same thing for number 7. Okay, so in number 7, they give us a 150 degree angle. Now, since we don't know what cosine of 150 is and sine of 150, we're going to need to find the reference angle that corresponds with this. Okay, so if we're in the second quadrant, here's our terminal side. If we want to find the reference angle, it's the acute angle formed between the terminal side and the x-axis. So this in here, let's say here's the x-axis, here's the terminal side, this would be our reference angle. Now let's think about how we could find how many degrees are in this angle. If we know that a half circle, a semicircle, is 180 degrees, and we know that this portion of it is 150, if we subtract 150 from 180, that'll leave us with this portion right here, which is 30 degrees. So our reference angle is 30 degrees. Okay, there's our reference angle. So now what we're looking for is cosine of the reference angle, cosine of 30 degrees, and sine of the reference angle, sine of 30 degrees. Let me just put the 30 degrees in here. All right, so here we're looking for, and I'll leave a space in case we have to insert a sign, cosine of 30, and then sine of 30. Okay, so now let's see, we're in the second quadrant. So if we think about all students take calculus, in the second quadrant, sine is the only trig function that we've learned about so far that's positive. So this sine of 30 we're going to keep as positive. But cosine is negative in the second quadrant, so let's insert a negative here. Okay, and then let's just figure out what this is equal to. So I'm going to bring down my negative. I just bring this down. And cosine of 30, here's cosine and here's 30, is equal to radical 3 over 2. Okay, and then this is positive. So sine of 30, here's sine and here's 30, is equal to 1/2. Okay, so these are the coordinates. If you were to go 150 degrees along the unit circle, okay, you would have to go back radical 3 over 2 units, and that's why this is negative, and then you'd have to go up 1/2, and that's why this is positive.